Lastly, we want to look at velocity, frequency, period, and energy of a charge moving in a field or magnetic field. Actually, for a charge moving in a magnetic field, it moves in a circular manner, and the force on it is given as B QV or VQB or QVP, whichever way you want to arrange it. But understand that if it's moving in a circular manner, there will be a centripetal force on it. The centripetal force is given as F is equal to mv squared over r. And this is the force that helps to keep it moving in a circular path. And that's equal to this actually. So it is the force that makes it, the exerting force that makes it moves in a circular manner. We can equate these two actually, and that will be that BQV is equal to mv squared over r. Well, we can eliminate one of the v's here, eliminate this, and eliminate this. Then we can now have that, if you cross multiply, that mv, or this over 1, mv is equal to what? bqr. And then we can see that the velocity can also be obtained by the equation bqr over m. This is the equation for velocity for an object, for a charge moving in a magnetic field. Again, we have it that velocity, but velocity is angular velocity times r. In that case, we have that omega r is equal to bqr over m. How can I eliminate one of the r here? We get that angular velocity is equal to bq over m. This is the equation for the angular velocity. So next, we have it that but omega is equal to 2 pi f, 2 pi times frequency. Now, if we equate that here, we get that omega 2 pi f is equal to bq over m. In that case, if you make f a formula, we get that this will be equal to bq over 2 pi m. This is the equation for frequency for the charge moving in a magnetic field. Again, if you want to get period, we know that frequency is 1 over period. In that case, this should just be that period is equal to, just have to turn everything upside down. That will be 2 pi m over bq. That's the equation for period. So this for period, and this for frequency, and this for angular velocity, and this for velocity. Already we can just get velocity from this, same force over bq. That's one way, or can get velocity with this, where force is not given. Now, the last is energy. We know energy is half mv squared. So that will be half times m times, we've gotten velocity already, to be bqr over m. So I'll put that here, bqr over m squared. And this will be 1 over 2 times m times b squared times q squared times r squared over m squared. So right here, m will eliminate one of the m here. So this will give us that the kinetic energy or energy is equal to b squared, q squared, r squared over 2m. This is the equation for kinetic energy or energy. Or kinetic energy. Actually, the energy we're talking about is kinetic energy because the electron is in motion. So that's that about this. Example 1. A proton moves in a 65 cm circular orbit that is perpendicular to a uniform magnetic field of magnitude 0.75 Tesla. A. What is the optical period for the motion? B. What is the speed of the proton? And C. What is the kinetic energy of the proton? Let's start now. Firstly, let's bring out what we are given. Since the proton, we know the charge on a proton is positive 1.6 times 10 raised to the power minus 19 coulomb. And again, the mass of the proton will be equal to 1.67 times 10 raised to the power minus 27 kg. Now we are given the radius of the orbit. The radius is given as 65 centimeters. So divided by 100, that will be 0.65 meters. Now we are given the magnetic field or magnetic flux density, 0.75 Tesla. Now the first thing is, what is the optical period for the motion? Well, we've said that period is equal to 2 pi m over bq. In that case, this will give us 2 times pi times mass of the proton, 1.67 times 10 raised to the power minus 31. Now divided by B and Q. The B is 0.75 times our Q, which is 1.6 times 10 raised to the power minus 19. Please, this is minus 27. So if we do this, we get that the period is 8.7 times 10 raised to the power minus 8 seconds. And this can be written as 87 nanoseconds. Now, for the B, we have to get the velocity. Velocity is given as B QR over M. The B is given as 0.75. That's what we have as the magnetic field. Times the charge, 1.6 times 10 raised to the power minus 19. Then times the R, 0.75. Okay, 0.65, sorry. So divided by the mass, 1.67 times 10 raised to the power minus 27. So the velocity will have it to be 4.6 times 10 raised to the power 7 meter per second. Now, lastly, for the kinetic energy or just the energy, we have it that kinetic energy is given as half mv squared. Now, we've gotten our V already, so no need of using the second relationship, which is given as kinetic energy is equal to B squared, Q squared, R squared over 2m. I don't need to use this since I already have my velocity. So I'll just say 1 over 2 times the mass, 1.67 times 10 raised to the power minus 27 times the velocity, 4.6 times 10 raised to the power 7. If we do this, we get our kinetic energy to be 1.77 times 10 raised to the power minus 12 joules. Please mind you that we have to square the velocity. But sometimes the energy is not expressed in joules, it's expressed in electron volts. Electron volts is another unit for energy. And how do you do that? You see, energy in electron volts is simply energy in joules divided by 1.6 times 10 raised to the power minus 19. So easy now. To be in electron volts now, it is, I'll just take the energy in joules, 1.77 times 10 raised to the power minus 12 divided by 1.6 times 10 raised to the power minus 19. This will give us 1.1 times 10 raised to the power 7 electron volts. And this can also be 11 mega electron volts. A 4.5 kilo electron volt electron move in a circular orbit that is perpendicular to a magnetic field of 0.32 Tesla. A, find the radius of the orbit. B, find the frequency and period of the orbital motion. Well, the energy is given as 4.5 kilo electron volt. That's 4.5 times 10 raised to the power 3 electron volts. But it's important to convert this joules in this energy in electron volt to joules. That's because our expression for energy are expression that should give you energy in joules. So since we see this energy, we have to convert to joules. That's 4.5 times 10 raised to the power 3, then times 1.6 times 10 raised to the power minus 19. If you convert it to joules, you must multiply by 1.6 times 10 raised to the power minus 19. And that will give us 7.24 times 10 raised to the power minus 16 joules. So that being said, again, the magnetic field B, 0.32 Tesla. That's the magnetic field. Now we have to get the radius of the orbit. Well, we know we have an equation for energy that says energy is equal to B squared, Q squared, R squared over 2M. If you multiply this, you get B squared, Q squared, R squared is equal to 2 times mass times energy. Again, we can now say R squared is 2ME over B squared, Q squared. If you take the square root of both sides, you get that R is equal to square root of 2ME over BQ. So this is what we have. Now, this is 2 times, since it's an electron, the mass of electron is equal to 9.1 times 10 raised to the power minus 31 kg. So that will be 2 times 9.1 times 10 raised to the power minus 31 times the energy, 7.24 times 10 raised to the power minus 16, square root of this, over square root of B over Q. B is 0.32 times the Q. The Q here is 1.6 times 10 raised to the power minus 19, since it's an electron. So 1.6 times 10 raised to the power minus 19, that's the value of the charge on an electron. So if we do this, we get that the radius here is equal to 6.96 times 10 raised to the power 10 meters. That's for the radius of the... Okay, so let's calculate the frequency now. That's the next thing we have to get. We know frequency is equal to BQ over 2 pi M. So this is equal to 0.32, then times charge, 1.6 times 10 raised to the power minus 19, divided by 2 pi times the mass. And the mass is an electron actually, so 9.1 times 10 raised to the power minus 31. So if we do this, we are going to get 909 or 9.1 times 10 raised to the power 9 Hertz. So that's the answer for our frequency. And then for the period is simply 1 over frequency. And that will be 1 over 9.1 times 10 raised to the power 9. If we do that, we're going to have 1.09 times 10 raised to the power minus 10 seconds. So that's that for this question.